Wheel alignment. Swift and sure steering responses are needed at today's driving speeds. To accomplish this, the wheels must be in alignment. Wheel alignment allows the wheels to roll without scuffing, dragging, or slipping on different types of road conditions. Proper alignment of both the front and the rear wheels ensures greater safety in driving, easier steering, longer tire life, reduction in fuel consumption, and less strain on the parts that make up the steering and suspension systems of the vehicle. Alignment geometry. The proper alignment of the suspension or steering system centers on the accuracy of the following angles. Caster. Caster is the angle of the steering axis of a wheel from the vertical, as viewed from the side of the vehicle. The forward or rearward tilt from the vertical line is caster. Caster is the first angle adjusted during an alignment. Tilting the wheel forward is negative caster. Tilting backward is positive caster. Caster is designed to provide steering stability. The caster angle for each wheel on an axle should be equal. Unequal caster angles cause the vehicle to steer toward the side with less caster. Too much negative caster can cause the vehicle to have sensitive steering at high speeds. The vehicle might wander as a result of negative caster. Caster is not related to tire wear. Caster is affected by worn or loose strut rod and control arm bushings. Caster adjustments are not possible on some strut suspensions. Where they are provided, they can be made at the top or bottom mount of the strut assembly. Camber. Camber is the angle represented by the tilt of either the front or rear wheels inward or outward from the vertical as viewed from the front of the car. Camber is designed into the vehicle to compensate for road crown, passenger weight, and vehicle weight. Camber is usually set equally for each wheel. Equal camber means each wheel is tilted outward or inward the same amount. Unequal camber causes tire wear and causes the vehicle to steer toward the side that is more positive. Camber angle changes through the travel of the suspension system are controlled by pivots. Camber is affected by worn or loose ball joints, control arm bushings, and wheel bearings. Anything that changes chassis height also affects camber. Camber is adjustable on most vehicles. Some manufacturers prefer to include a camber adjustment at the spindle assembly. Camber adjustments are also provided on some strut suspension systems at the top mounting of the strut. Very little adjustments of camber or caster is required on strut suspensions if the tower and lower control arm positions are in their proper place. If serious camber error has occurred and the suspension mounting positions have not been damaged, it is an indication of bent suspension parts. In this case, diagnostic angle and dimensional checks should be made on the suspension parts. Damaged parts should be replaced. Toe. Toe is the distance comparison between the leading edge and trailing edge of the front tires. If the leading edge distance is less, then there is toe in. If it is greater, there is toe out. Actually, toe is critical as a tire wearing angle. Wheels that do not track straight ahead have to drag as they travel forward. Excessive toe measurements, either in or out, cause a sawtooth edge on a tread surface from dragging the tire sideways. Excessive toe in will cause tire wear on the outside edge of the tire. Toe out cause wear on the inside edge. Toe adjustments are made at the tie rod. They must be made evenly on both sides of the car. If the toe settings are not equal, the car may tend to pull, due to the steering wheel being off-center. This pull condition is especially common with power-assisted rack and pinion gears. It can be corrected by making the toe adjustments equal on both sides of the car. Toe is the last adjustment made in an alignment.